for those of you who don't know me, my name is Umair Ahmed. I'm a Senior Technical Product Manager within the Network and Security Business Unit at VMware, and I have with me here Richard Stinton from Ireland. And what we're going to do is we're going to talk about, in this session, disaster recovery solutions with NSX. Okay? Now, I always say this at the beginning of my sessions because they tend to be pretty technical, advanced sessions. This is an advanced level session, so the assumption is you do have some basic knowledge of NSX. And we have a lot of content to cover, but feel free to ask questions along the way. We're running short on time, I'll let you know, and we'll also be sticking around after the session. So if you have any additional questions or want to talk about anything specific, you can do so at that time. All right? So quick disclaimer, I'm always forced to show. Let's move on, and we'll start for the need for better disaster recovery with NSX. You can see here we have a lot of content here, and I added a section. I presented this in the US VMworld as well, and I added this last section 7 for third-party services to show some additional cool things there. So when we talk about traditional challenges for disaster recovery, what are they? Okay, change in application IP address, because now you're mapping networks between your protected and your recovery sites, right? And because you're trying to keep that consistent, you're remapping your IP address. Otherwise, if you're trying to keep the same networks, you're recreating your physical L2, L3 connectivity requirements for your applications, right? And what about security policies? Even if that network is available on the other side, your security policies, you have to now either recreate them or have some automation you have to do to enable that. And you might have other types of physical device configuration, load balancers, firewalls, and so forth. You might have ACLs and other application dependencies, right? So a lot of challenges there. And when we look at these traditional challenges, what are some traditional solutions? You have things like L2 over dark fiber. Now you have to concern yourself about loop avoidance issues, VPLS over MPLS backbone, right? Complicated, requires some lead time. You might have a hardware-based solution like OTV. Now you need the same hardware on both ends. And really all of these solutions are only really focusing on the network. They're not really solving all the problems and traditional challenges that we have. So they're expensive, hardware-based, complex, operationally challenging, and as I mentioned, may require long lead times. Now, who in this audience has deployed disaster recovery solutions? Okay. So are some of these challenges, do they sound familiar? Yeah, so I see a lot of folks shaking their head. Yeah, so these challenges have been around for quite a while. And really what I'm mentioning here is, the point I'm trying to make is they're not holistic solutions. They're only focused on the network and per device configuration, and they lack the automation and flexibility we really want and desire. So what we want is a software-based approach, stuff that can provide decoupling from the physical hardware, ease of deployment, ease of use, better security with micro-segmentation across sites. We want to be able to leverage higher level security constructs like security tags, not just IP addresses, which can change and provide no context. Flexibility in terms of deployment, a high degree of automation, rapid deployment and recovery. We want to be able to easily test our disaster recovery plans. This is a big one. We'll talk about it in more detail. Extensive partner ecosystem for services. What if you want to leverage advanced application level security? We'll see an example of that later on with Palo Alto Networks. And other integration with disaster recovery and software-defined data center components, SRM, vSphere, vRealize Suite, and so on. Now, NSX can provide all of this. Okay? So let's look at some specific features in regards to disaster recovery. Now, before I go into this, who here has deployed already disaster recovery solutions with NSX? Anyone? Okay. All right. So this hopefully will be interesting, and you'll take away some good things there. And go back, and next time I ask this question, I'll see a lot of people raising their hands. Out of the people who deployed disaster recovery solutions, what are you using today? Veeam, okay. Okay, you are using, but just not NSX today. Okay. SRM, but not NSX, okay? So great. So hopefully what you'll take away from this session is you'll see, because I'll step through some examples, and the person who mentioned VMware, you know, the nice thing is NSX is agnostic to the disaster recovery orchestration tool you use. Last year I showed a demo with SRM. Here I'm going to show a demo with Zerto. The point I'm going to make is it doesn't matter to us, but you'll still get a lot of the benefits I'm going to show here, okay? So we'll start with this example. You have Site 1 and Site 2, and with a feature called Cross vCenter NSX, I can basically deploy universal networks across vCenter domains across sites. And typically, customers who have multiple sites will have multiple vCenters, a vCenter at each site. So Cross vCenter NSX allows us to deploy these universal networks across vCenter domains and across sites. And how that works is, and I won't go into all of the details, there's some other sessions you can attend to get some of that information, but just as a refresher, you have a primary NSX manager here, okay? You have a secondary NSX manager here. On this primary NSX manager, you come and create universal objects, like universal logical switch. That configuration automatically gets synced to the secondary NSX manager and gets pushed down to the respective hosts. Okay, so that's how I can create these universal objects, like universal logical switch, universal distributed logical router for my east-west routing within the software-defined data center, my universal distributed firewall for advanced level security and microsegmentation across vCenter domains and across sites. So now I have this consistent networking and consistent security across sites, and on top of this, I can deploy ESGs, which are basically my ingress-egress points out of my in and out of my software-defined data center. And this active application at Site 1, I can control all the traffic and say it should go out to Site 1 ESGs using routing protocols and routing metric. In this case, perhaps I'm using BGP, and I'm giving these ESGs at Site 1 a higher BGP weight than the ESGs at Site 2. Okay, so all traffic will be forced out of there. Now, if this application goes down, or even if the entire site goes down, my disaster recovery orchestration tool, whether it's SRM, Zerto, RP for VM, will bring up those workloads at Site 2, and the Site 2 ESGs will be leveraged for ingress-egress. So first slide, and on this first slide, you can already see a lot of those challenges have dissolved. You have consistent networking, consistent security, you know, and some inherent automation. Okay, so we'll continue here, and you'll see some additional advantages. And hopefully by the end of the session, you'll all be very impressed and go home and buy NSX right away. Okay, so here we have flexibility for disaster recovery solutions. So what I mentioned is, you know, there's a lot of benefits with consistent networking and consistent security, right, and automation. But one of the great things about NSX is the flexibility, because you have everything in software. So you can easily come up with these different types of topologies. So here I have an active application at Site 1, the standbys at Site 2. It's that topology I just showed you. With a click of a button, I can very easily deploy another UDLR, okay? And I can connect additional logical switches to this UDLR. Now on this guy, I can deploy my workloads at Site 2, and these are going to be active here and standby at Site 1. So now I have bidirectional DR, where my application at Site 1 is leveraging the Site 1 ESGs, and my application at Site 2 is leveraging the Site 2 ESGs. So I have bidirectional DR, and I'm using resources at both sites, including the ingress-egress points. Very easily to do in software, very difficult to do with hardware. Okay. Now, what I mentioned so far are some of the benefits in terms of networking, security, you know, automation, the flexibility in deployments. On top of that, we're always adding enhancements to NSX. So one of the enhancements we added in NSX 632 is enhancements to the NSX control plane, or the controller cluster. So before I go into the details here, I should mention the universal controller cluster already has inherent resiliency. The reason is because you're natively leveraging vSphere HA, and it's a cluster. So what are clusters used for? Right, they're used for scaling out and resiliency, right, by definition. So you can lose one node here, and your control plane keeps functioning. In fact, because NSX has complete separation of data plane and control plane, you could lose the entire control cluster and your data plane keeps forwarding. Okay? Now on top of that, we added even additional resiliency for niche corner case, which I'm going to explain here. And before I explain that, I'm just going to do a quick refresher of the control cluster. So what is this control cluster and what does it do? Well, as these control clusters, basically what it does is it knows the entire state of the network. Okay? So as this workload comes up, this control cluster is notified, hey, this VM is on this logical switch on this host. Now, a logical switch is basically a VXLAN, and it is a termination endpoint. It's called a VTAP, VXLAN termination endpoint. Every host has a VTAP, right? So when this workload comes up, this control cluster is notified, hey, this VM is on this logical switch behind this host, behind this VTAP. So now when this VM on the left wants to communicate to the VM on the right, this host 1 gets the information from the control cluster, and this communication is successful. Now, even if the second VM moved to the host 2 on site 2, the communication would continue to work because the control cluster would get notified. That information would be propagated to the other hosts. Okay? However, what about the rare circumstance or situation where the control cluster does go down or you lose the entire control cluster? Again, communication continues to work because data plane's already programmed. But what if the second VM moved to host 2? Well, this host 2 was never a member of this logical switch. This VM moved to this host 2, so now this host 2 becomes a member of the logical switch, but he can't communicate that to the control cluster because the control cluster is down and the control cluster can't propagate that information to the other hosts. So this is where you would have data plane disruption. And this is a specific enhancement we did to tackle this specific scenario to give you even additional resiliency to what's already there. Okay? So now I can enable what's called CDO mode on my transport zone and have a universal transport zone here. As a refresher, what's a transport zone? It's the boundaries of my networks. And here I have a universal transport zone, so it's the boundary of my universal networks. And I define, or you define, what clusters and hosts are part of that transport zone. So I enable CDO mode here. What happens in the back end is something called a CDO logical switch gets created. And all hosts that are part of that transport zone, that are members of that transport zone, join that CDO logical switch. And what's called a global VTAP list gets created, which is basically a list of all the VTAPs of all the hosts in that transport zone. So keep that in mind as I walk through the next flow. So now, same situation, but I have CDO mode enabled, control cluster goes down. Again, rare event, but let's assume here. Now, the second VM moves to host 2, communication continues to work. So why? How is this possible? Well, we're not using the universal control cluster here. What we're using is that global VTAP list. And the bump traffic is basically broadcast to all the VTAPs to allow the communication to continue to work. So again, additional resiliency to what's already there for this niche corner case. Now, so let me stop here because I know I'm that's a lot of information in just a couple minutes. Any questions so far? Okay, feel free to ask along the way. So now in NSX 6.3, we added even additional enhancements to the security. So that's what I'm going to talk about here. Some of you may remember prior to 6.3, when I'm using universal distributed firewall rules or universal security policies, I could only leverage universal security group, universal IP set, universal MAC set. Starting with NSX 6.3, I can also use VM name and universal security tag. So now I can actually create universal security groups with matching criteria based on universal security tag and VM name for active standby deployments. Okay? And I'm going to use the universal security tag example here. So first thing I do is on my primary NSX manager, I go to the installation tab, I go to my primary NSX manager, and I set what's called a unique selection criteria. So what is this? Well, when I create a universal security tag, it automatically gets synced to my secondary NSX manager. Syncing the security tag is one thing, right? But what about when the workloads actually fail over or are moved to that secondary site? How does that local NSX manager know what tags should go to what VMs, right? And that's what the selection criteria is used for. So we provide you several options here: virtual machine instance UUID, virtual machine BIOS UUID, and virtual machine name. Now, for most scenarios, we'd recommend use the virtual machine instance UID. Typically, that's sufficient. It's not guaranteed to be unique across all vCenters, but it's very rare that there would be overlap. For instance, when you're replicating with vSphere replication, it makes sure it maintains that instance UID, so when your workloads fail over and they're coming up, you can be assured the correct tag will get applied and you'll get the correct security policies. However, you could use virtual machine BIOS UID or virtual machine name, or a combination. Now, if you use virtual machine name like I'm using here, you just want to make sure all your VMs have a unique name, because that's being used as the unique identifier, right? So first thing I do is set this unique selection criteria. Second thing I do is on the primary NSX manager, I create that universal security tag. And you can see I'm just basically checkboxing, this box here saying, mark this for universal synchronization. That is basically saying, okay, this security tag is going to be universal. Okay, this option wasn't there prior to 6.3. So I create that universal security tag, and it automatically gets synced to my secondary NSX manager. Now, on the primary NSX manager, I go and I make sure I put that tag or attach that tag to the correct VMs. Okay? So now when I have a disaster recovery event, or when my workloads fail over and aren't being brought up by my disaster recovery orchestration tool, the tags get applied based on that unique selection criteria I selected, and based on that security tag, the correct security policies are applied. Okay? That's how that works. Any questions there? Yes?
Is there any reason not to make all your security tags universal?
Yeah, I mean, this question comes up. So, there's different tools, there's different environments that people have. So we wanted to give the flexibility. Now, when you use multiple options, there's some additional, calculation that has to be done based on those options. This is very dependent on the environment. For example, like SRM replicates the instance ID, so you can use that. You can use VM name. If you use Zerto today, that instance ID isn't replicated, so I use VM name. But even with Zerto, you'll see there's some things you have to consider. So we just wanted to give the option to customers, based on their environment. Hey, set this to what you need it as.
But the security tags, is there any reason not to just choose them all to be synchronized?
Choose them all to be synchronized? Oh, okay. You're asking why not just make them all universal security tags? Well, you may not desire that. You may not want that. You might want local tags only, right? You may not want to use universal security policies. So you might have some local policies where you just want to use local tags and you don't want it synced to the secondary site. So again, it depends on your design.
So there's no limits that you should be aware of?
In terms of what?
I don't know.
I mean, there are some numbers. So if you have concerns about, we validate to what most of our customers use. So typically, if you're, any customer deploying this feature, typically the limits will be fine. If there's some concern, we can look at that and just validate. It's all software, so it's a matter of validation, right? Yeah. But whether to use local or universal depends on, your requirements. Do you want this policy to be a universal? Do you need that synchronization? Or, if not, then you can use local. Now, I guess if you're asking any kind of limitation, in this design I mentioned, you can only use this for active standby deployments. So you can't use this where you have an application that's spanning both sites and you have policies between them, right? And the reason for that is, so what I'm saying there, what I mean by that, the application has to be completely on this side, like the 3-tier application, or on this side. You can't have, say, this web VM here and the database VM here, and say the web can't talk to the database. Right? The complete application either has to be here or here. That's why I say it's specifically for active standby deployments, right? And the reason for that is this NSX manager here doesn't have visibility into the vCenter inventory here. So even though the tag is applied correctly here, when this guy, the policy here is saying web can't talk to database, it'll work over here, but he'll never see this guy here with the database tag. So it's active standby deployments only. Okay. Does that answer your question? Anything else? Okay, so let's move on. So now, so far I talked about doing disaster recovery with NSX between private data centers. And what I want to make clear here is you can also do this to a cloud environment. So in this case, I have site 1, which is local. I might have another cloud environment or another data center, say within a cloud environment, perhaps a VMware cloud provider like IBM Cloud. And we have many customers today who have direct connectivity to IBM Cloud, so they can do L2 over L3 via cross vCenter NSX. So then they get all the benefits of that consistent networking and consistent security across sites. The active application may be local, and the standby could be within the cloud environment. Okay. Now, this is one way to do it, but you'll notice this session title is called Disaster Recovery Solutions with NSX. Okay, not Cross vCenter NSX. So you can use Cross vCenter NSX here for this enhanced kind of disaster recovery model, but there's other options too. Let's say you don't meet some of the requirements of Cross vCenter NSX. Another way to do it is you could have site 1 local. Again, you could have a site 2 within a cloud environment. Could be IBM Cloud, could be another VMware cloud provider like Island. Richard's going to present here on how they're using NSX with Island today. And you could do IPsec. So you can use NSX to do IPsec between the sites. Your active application could be at local. Your standby could be within the cloud environment. Now, you can also do L2 VPN, where you're extending L2. So now you can cover, scenarios like partial application failure, right? So that's one of the great things I would say about NSX2 is like you have flexibility. You're not forced down one path. What are your requirements and what will accomplish or what will meet those requirements? Okay. So let's look at some specific solutions with examples here. So what do you need for this enhanced disaster recovery model with Cross vCenter NSX? Well, you need vSphere 6 because that's where you have the Cross vCenter vMotion functionality. You need NSX 6.2 because that's where we introduced Cross vCenter NSX for that consistent networking and security across vCenter domains. For your DR orchestration tool you use, we're agnostic to that. So it could be SRM, it could be RP for a VM, Zerto Veeam, or some other disaster recovery vendor. For storage replication, you have lots of options. Could be vSphere replication, array-based replication. You could be leveraging RP for VM for replication or using Zerto for replication, right? So let's take a look at an example here with SRM. So Site Recovery Manager, you have an appliance for managing your recovery plans, and there's tight integration with vCenter. So you log into with the vSphere web client, you'll see a plugin for SRM, you'll see a plugin for NSX. Okay. Now here for compute, that's handled by the vSphere hypervisor. For storage, you have lots of options as I just showed you. What about the networking? This is where NSX comes into play. And with SRM, we have some additional integration where when you're using storage policy protection groups, it can actually do automatic mapping between the source and destination network. Because you're using universal networks, it sees the same network on both sides. So you can click a button and it can do this automatic mapping between the networks for you. It can save you a lot of time if you have a lot of networks. Okay. So let's walk through a workflow here. So here I have two sites, primary NSX manager with its vCenter here, secondary NSX manager with its vCenter here. I have universal networks going across my sites and universal distributed firewall for my universal security as well. So here you can see I have a primary NSX manager and its respective vCenter, a secondary NSX manager and its respective vCenter. And there's only 3 controllers, within a cross vCenter NSX environment, similar to a local environment, but you're seeing 6 rows down here. The reason for that is because what this is actually showing you is the status between each of the NSX managers and each of the controllers. So since there's 2 NSX managers and 3 controllers, you're seeing 6 rows. But the bottom 3 here are the controllers. If you look at the IP addresses, it's the same 3 IP addresses to each of the NSX managers. Okay. So I have my consistent networking and consistent security across sites. I could also be leveraging higher level security constructs like universal security tags. Okay. Now, I could also be leveraging third-party security like Palo Alto Networks for application level security. Now I deploy SRM in my management layer. For my disaster recovery plans, I have vSphere replication deployed within my clusters. I have my active application at Site 1. It's using the Site 1 ESG again. I'm controlling that by routing metric. I'm using BGP weight here, giving the ESG at Site 1 a higher BGP weight. And my vSphere replication is replicating my active application workloads to the recovery site. Okay? So now when this application goes down, my disaster recovery orchestration tool, in this case SRM, can bring up those workloads, and I can use priorities to bring up the database app first, and then the application tier, and finally the web tier. So when the web VMs come up, all the backend services are already taken care of. So my universal security tags here will get applied to the correct VMs based on that unique selection criteria. So now I have consistent networking, consistent security, and I can still leverage the Site 1 ESGs if it's still up. However, I have many options here. I can also leverage the Site 2 ESGs, but I may want to leverage the Site 1 ESGs here because it's still up and it might be a temporary where I'm going to move this application back. A lot of different deployment options you can use there. Okay. Now, so far I've mentioned a lot of benefits in terms of using NSX, right? There's consistent networking, consistent security, higher level security constructs like security tags, automation, flexibility in terms of deployment, some of the additional resiliency we've added. But in my opinion, one of the best things about using NSX with a disaster recovery orchestration tool is you can easily test your disaster recovery plan. So, in the news today, in the media, you see a lot of outages here and there, and you wonder what happened there. Did this company not have some kind of disaster recovery plan? And the reality is they probably did, but they just didn't effectively test that disaster recovery plan. So what NSX does is allows you to easily, do that testing. So let's look at how that works here. Here I have a production network. I have an active application at Site 1. Okay? With a click of a button, I can very easily create a test network, a test UDLR, test universal logical switches with the exact same IP addressing scheme, using the exact same security policies. I don't even have to do anything, right? All I'm doing is just creating these networks and just, they can use the exact same IP addressing scheme. I don't have to do anything in terms of security, no manual configuration there. So what happens is when SRM or whatever tool you're using, you run that test, it can bring up these workloads. You can configure it so it brings up these workloads on the test network. So now your application will come up on the test network. It will have that exact same IP address. It'll have the exact same security policies, and there'll be no disruption to your production environment because you're running on a completely isolated test network. So pretty cool stuff here. And again, in my opinion, one of the best things about using NSX and some kind of DR tool together. So a quick question here. Out of the folks who have disaster recovery today, how are you testing your disaster recovery plan? You're not, or? Separate. So you have to manage all of this separately, right? Not easy to do. And then the security policies, do you even test the security policies? Yeah, no, right. So, think about that. Like, you're testing your disaster recovery plan. I've asked this question to a few folks, and they're like, well, yeah, you have to manage, you're creating all these VLANs for your different applications, and then you have to have some downtime sometimes. And when I ask about the security, it's like, well, just get a bunch of question marks, and they're like, well, it's probably not there. But think about that. Your application is recovered, and it's vulnerable, right? So, a lot of benefits there. You're able to test, with the networking, with the security, and when the failover actually happens, you can be assured not only does your application recover, but it's not vulnerable, right? Otherwise, you could be looking at a whole new mess if you get hacked or something, right? So I used an example with SRM there. So the point I want to make here is we're agnostic to the tools you use. So you could use something like RP for VM, very similar in terms of deployment, where you have an appliance that manages your recovery plan. It has integration with vCenter, so you log in through the vSphere web client. You'll see that plugin there. It has an appliance that's doing that replication. Or you could do something like, you could use something like Zerto. Again, in terms of deployment, very similar, where you have a Zerto Virtual Manager, where you're creating your recovery plans. I've deployed here in the management layer, and then I have appliances deployed in clusters that are doing that replication for me. Okay.
So effectively, it's not mandated to have vSphere replication for this NSX failover, right? For stretch to doing the orchestration by NSX.
Well, so SRM is helping with that orchestration. It's a disaster recovery orchestration tool. So vSphere replication is actually what's replicating that VM, and they can work hand in hand together. But you can also use array-based replication, or you could use Zerto, or you could, I mean, there's different tools.
You could use Zerto or any of those.
Yeah, you could use any of those tools.
You don't have to use SRM.
You don't have to. Now, well, if you don't use SRM, you won't have that orchestration to recover your workloads. So, you know, there's lots of different types of deployments you can do with NSX, where perhaps you don't need a disaster recovery orchestration tool. How many of you are familiar with vSphere Metro Storage clusters? So a few folks. So you know you can use NSX there too, and it's a simplified disaster recovery, not really full-blown because you don't have these disaster recovery plans, but it uses vSphere HA, and it can bring up those workloads on the same networks, right? Now, if you're not using a disaster recovery orchestration tool here, you know, you can still do vMotion between the sites and do disaster avoidance. But if you really want a full-blown disaster recovery or, you know, a solution, then you need something like SRM, Zerto, or RP for VM, Veeam, something like that, combined with NSX. Okay, so it depends on what your end goal is.
No, but I'm just saying, if I use Zerto or RPM, this recovery point, then I don't have to use as a prerequisite SRM as well, along with that.
No. Yeah, you could use one or the other, or if your requirements don't dictate, you don't have to use any of them.
What do you call that for?
Which one?
Micro something?
Zerto.
vSphere micro?
There's vSphere Metro Storage Cluster. Yeah, so that's a particular design where you're stretching clusters. You know, you're stretching clusters across sites. And because you're stretching clusters, you need a stretch storage solution. And what happens there is because you're stretching clusters between sites, you can leverage the HA and DRS capabilities of those clusters. Yeah, well, it's a specific solution where you're stretching the clusters. And a lot of these the examples I'm showing, I'm not stretching the cluster. So when you stretch the cluster, you can leverage vSphere HA for that simplified kind of, you know, what I call simplified disaster recovery. Okay. All right, so let's go on here. So now let's look at a demo, since you kind of have a good understanding of NSX and, you know, how it benefits these disaster recovery solutions. So I have two sites here, Palo Alto, San Jose, and my cross vCenter NSX setup. And I'm going to my web VM here, and you can see it's on the subnet ending in 8.1. It's on my universal web logical switch. Okay. I have another web VM on the same subnet on the same logical switch. I have an app VM on a different subnet ending in 9.1 on universal app logical switch. And then I have my database VM on a different subnet ending in 10.1 on the universal database logical switch. I have a 3-tier application here. So if I go and look at the security policies here, I'll see basically I'm going here to my distributed firewall, and I'm looking at my universal section here for my universal policies. I'm using security groups here, and you can see I'm basically letting all of the tiers talk to each other. Web, database, app, they can all talk to each other. Okay, so if I go to my primary NSX manager here, and I click on security tags, you can see I created a universal security tag for my web tier, and I've attached it to my web VMs, the 2 VMs I showed you. I did the same thing for my app tier. I created a universal security tag for my app, and I attached it to my app VM. Same thing for the database. I created a universal security tag for my database tier and attached it to my database VM. Okay, so I'm using security tags there. Now if I go to security groups, you'll see here, I've created these security groups. I've created a web universal security group for my web tier. And I'm basically saying here, put all VMs in the security group that have this universal security tag of web. And I've done the same thing for the app and database. I just showed you one there to kind of save time. So now if I go to my web VM and I ping the app VM, of course I can communicate. And I can also communicate to the database VM. And again, this is expected because you saw in my distributed firewall rules, I'm basically allowing all the tiers to talk to each other, right? And if I go to my, so here I'm going to also go to my app VM, and I'm going to show I can also ping the database VM. So from the web VM, I can ping the app and database. From the app VM here, I can also ping the database. Again, all is expected. So what I'm going to do now is I'm going to go to my policies that I just showed you, and I'm going to go to my last two rows, and I'm going to prevent the communication between the web and database tiers. And you can see in these policies, I'm using those universal security groups based on those security tags I just showed you. So I'm just going to do a quick block between the web and database because I want all that communication to the database to go through the app tier. Okay, so I'm just going to do block here. And now if I go here and I try to do a ping to the app VM from the web, again, I can still communicate, but if I try to ping the database VM, I should no longer be able to communicate to it. And you can see that is indeed the case. So we can see those policies are working or are in effect now. And if I go to my app VM, I still should be able to communicate to the database from this guy because I only prevented web to database. And that is indeed the case. So now I'm going to go to my Zerto and go log in here. And I can see I'm at the Palo Alto site. Okay. So I'm going to click VPGs here. And you can see the pure site is San Jose. I'm going to click into this tenant. And I can see my SLAs being met based on my requirements. I can see there's 4 protected VMs. If I click the protected VMs, you can see the 4 VMs I'm using, the 2 web VMs and the app VM and database VM I showed earlier. Okay. Now if I click sites, I can see the source clusters and the source site and the destination cluster and the destination site where these VMs are being protected to. And if I click here, I can see the default failover and test networks. I can click farther in, and I can actually, at the VM level here, select the VM and specifically set the failover and test networks for that VM. So here you can see the failover network, here you can see test network. So for my failover network, it's actually going to be that actual production network. Okay? So here that was Universal Web. And this one is going to be the test network I created. It's going to be test Universal Web. Okay? So I'm just going to go ahead and click cancel here. I already did all of this to save some time. And what I'm going to do now is I'm going to test, I'm going to test this recovery plan. So you can do a live failover, you can do test. I'm going to do a test here. Just click next. And I'm going to start this failover test. When I start that, you can see the process here running. And when it completes, I'll go ahead and go to my recovery site, San Jose, and you can see those workloads have been brought up with the testing recovery appended to the VM name. So if I go to my web VM, I can see it's actually brought up on that same subnet, same IP address, and same on that test network that I'd configured. Now, when Zerto does the replication, it today doesn't maintain that instance ID. I believe that is the intention eventually, but right now it doesn't do that, so I'm using VM name. But you can see, it appends this testing recovery. So within Zerto, you can actually run a script, and what I did is ran a script when it did that test to remove that testing recovery text because I'm matching based on that VM name for my security tags, right? Now, when you do a live failover, it doesn't append that text. So this is just in that testing case. And again, I believe the intent is in the near future, very near future, that they will allow you to also have the option to maintain the instance ID. So here you can see I'm pinging the app VM from the web VM at my recovery site. But if I try to ping the database VM again, it's not allowed. So what this is showing you is I'm using those security policies based on security tags, and it's consistent from my protected site to my recovery site. If I go to my app VM, I'll still be allowed to communicate to the database as expected. Now, if I'm using SRM, it does maintain that instance ID, and you can also use VM name. So again, that's why we give you those options based on your environment and the tools you have. Okay? So hopefully that demo, kind of brought home to you of some of the capabilities that we discussed earlier. Now, now that we kind of went through some of the basics and you understand some of these benefits NSX adds to these disaster recovery solutions, I want to look at some customer examples. And the first one we'll look at is Dell EMC Enterprise Hybrid Cloud. Okay? And this customer particularly is leveraging cross vCenter NSX to provide their customers enhanced disaster recovery solutions. Now, we'll look at a particular use case. But before we do that, let's at a high level just understand what enterprise hybrid cloud is. So first, you start with a converged infrastructure. So it can be VxRail, VxRack, VxBlocks. On top of that, you add some software from VMware and Dell EMC, vSphere, NSX, vSAN, Viper. Now, on top of that, for your cloud management and operations, we're leveraging the Realize suite. So you have Realize Automation, Realize Orchestrator, Log Insight, so on. Now, all three of these combined basically give a self-service and automated infrastructure as a service platform for customers. Now, on top of that, what Dell EMC has done is they have this custom engineered solutions for multi-site continuous availability disaster recovery, and we'll look at the disaster recovery use case in more detail. But in a nutshell, this is pretty much what Dell EMC Enterprise Hybrid Cloud is. So we're all on the same page here, okay? So now for this Enterprise Hybrid Cloud leveraging NSX, there's lots of customers using some of these solutions. And here I have some of the public reference customers. And you can see, this Enterprise Hybrid Cloud solution with NSX, customers are getting faster provisioning, reduction in downtime, obviously reduction in costs as well. So let's look at the disaster recovery use case. And here for disaster recovery, really two main products are being leveraged, NSX and RP for VM. So RP for VM is Dell EMC's product basically for replicating workloads. So a couple things to mention here is it's providing VM level disaster recovery granularity. It's a virtual appliance that can do the replication. It also has vSphere web client integration, okay? So now we're going to look at specific requirements from a customer. When I say customer, I'm saying Dell EMC Enterprise Hybrid Cloud's customer. So they had customer had these couple requirements, and then we're going to look at the solution that meets these requirements. So first requirement was 2 sites, 2 vCenters. You need a solution that will work with this. Second requirement is active workloads at both sites. It's a must. They want active workloads at both sites. Third requirement is they want bidirectional disaster recovery, meaning they want application active at site 1 and standby on site 2, and they might have another application active on site 2 and standby on site 1, so bidirectional disaster recovery. They want consistent security policies across vCenter domains, across sites, and when the application moves, it should maintain those policies. They want consistent networking across vCenter domains, across sites, with the ability to do traffic engineering. They also want to be able to do DR consumption through a cloud management platform. So these are the requirements, and now we're going to look at the solution. So we'll start with building the network. We have 2 sites here, NSX Manager on site 1, secondary NSX Manager at site 2, with the respective vCenters. And first we deploy a UDLR. Okay, and I'm just going to call this a green UDLR, and the requirement here is all the traffic is sent out to site 1 ESGs. How am I controlling this? Using routing metric, BGP in this case, with BGP weight. I'm giving the ESGs at site 1 a higher BGP weight. I have another UDLR I deploy, and similarly to the first case with the green UDLR, I have ESGs, in ECMP mode across sites. I'm giving the ESGs at site 1 a higher BGP weight, so all traffic, or in this case, site 2 a higher BGP weight. So green, the site 1 ESGs have a higher BGP weight. Blue network, the ESGs at site 2 have a higher BGP weight, okay? So for my blue network, all traffic goes out the site 2 ESGs, okay? Now I have applications connected to both of these networks, to the green network and to the blue network. The applications connected to the green network will obviously go out the Site 1 ESGs. The application connected to the Blue network will go out the Site 2 ESGs. Again, why? Based on my routing protocol and routing metric that I've explained. Okay. So right here, we've already knocked out 3 of the requirements. First, we have 2 sites, a single vCenter at each site. Second, we have that consistent networking across sites, and I'm able to do traffic engineering with routing protocol and routing metric. Third, I have active workloads at both sites. Okay. Now, what about protecting the workloads or replicating the VMs? This is where we're leveraging RP for VM. Okay. So I have my green application and I have my blue application. And within RP for VM, I've created these consistency groups, which is basically just a logical grouping for the application. So for my green application, it's being replicated to Site 2, and the placeholder VMs are created there. And for my blue application, it's being replicated to Site 1, and the placeholder VMs are created there. So here I basically knocked out that requirement of bidirectional disaster recovery. Okay. So now what about securing the application? Right, security is a big requirement here. So what I'm leveraging here is basically universal security groups, universal security tags, and distributed firewall rules. So when I create these objects on my primary NSX manager, they're automatically synchronized to my secondary NSX manager, to my secondary site. Okay, so now I can create these policies on my primary. They're pushed down and applicable to the applications at both sites. Now, for applications that are spanning both sites, I'm using IP sets, right? And for applications, as I explained earlier, that are always going to be completely on Site 1 or Site 2, very active standby, scenario, I'm leveraging the new enhancements where I can use universal security group with matching criteria of universal security tags and VM name. Okay, so here we've knocked out that requirement of consistent security between vCenters, between sites. When the application's moved, the security policies are still correctly applied. The correct security policies are applied. And also there's the last requirement here was to leverage a cloud management platform system. So with VRA, NSX already has a number of workloads that are provided. And what Dell EMC did is they created additional workflows that incorporate some functions you can use with RP for VM to give you that disaster recovery as a service solution. Okay? So hopefully you've taken away from that example how Dell EMC Enterprise Hybrid Cloud leveraged the cross vCenter NSX functionality to provide this enhanced disaster recovery solution for their customers. Now, what I want to do is hand off to Richard, who's going to explain how Island, used NSX in a different way to provide disaster recovery solutions for their customers. Richard?
Thanks. Thanks very much. Okay, so what I wanted to do now was just really explain some of the solutions that we provide, which is adding to a lot that Humair has been talking about. Just really to introduce myself, I was with VMware for 7 years in the early days, working in the Cloud Center of Excellence in the early days of vCloud Director. Then been out in the VMware cloud ecosystem, spent a short time at Microsoft Azure, realized the error of my ways, and now I've come back into the VMware community, working with Island. Just a little bit about Island. We're in the Exhibition Center at booth E603 if you want to come and talk to us later. Spot the blue t-shirts. But we've been around 22 years, but really for the last 11 years we've been focusing on cloud solutions, and we really focus on disaster recovery as a service. So we're partners with Zerto, with Veeam, with VMware, and we're right up in the top right on the Gartner and Forrester quadrants for disaster recovery as a service. We do 3 things, and we try and do those 3 things really well. So the main thing we do is disaster recovery as a service, and we do that with the 3 main solutions out in the market really for VMware. So we do that with Zerto, we do that with Veeam, and we've just recently at Vegas announced vCloud Availability, which is vSphere replication to the cloud. We also do infrastructure as a service and cloud backup, where we're Veeam's largest cloud provider for backup to the cloud. 8 data centers around the world, so we've got global coverage. Not going to go into great detail on these slides, and so come and talk to us if you want to know more about the actual company. We've been on this journey with VMware since the early days of vCloud Director, when we were using what was called vShield Edge. That's then sort of migrated into vCloud Networking and Security. So we've been deploying, from VCNI, as it was called, VXLAN, and now into NSX. So we've got over 10,000 virtual networks deployed within our customer networks, leveraging VXLAN technology at the moment, typically with VCNI, but also deploying private VLANs, typically for customers that are bringing in MPLS circuits to us and that sort of thing. But we're now leveraging NSX extensively for both customer on-prem to cloud, but also for our cloud-to-cloud DR capabilities. One thing we're seeing is massive performance improvements over the VCNS edge. So we're seeing a consistent 8 gigabit throughput between NSX edges in our different data centers over the public internet. So really just, common use cases. Customers are looking for a multi-tenanted DRAS solution. Benefits of this is that we only charge for storage until you invoke DR. So it's much, much more cost effective than building out your own secondary DR site where you're having to populate your own hardware. It's only when you spin up in DR that you pay for CPU and RAM. But, I'm not going to go into all the detail that we've already been through with VMware, in the context we're down to kind of 7 minutes here. So the key use cases really are partial failover. So we think about full failover as a smoking hole in the ground scenario. So in that idea, there may be no data center here anymore. So the networking between data centers doesn't really matter quite so much. So you can just bring everything up on the same IP addresses in the DR data center. The more common use case is the idea of partial failover. So have we lost some ESX hosts? Have we lost a SAN? Something like that. You want to just partially fail over. This is where NSX is going to be massive for us compared to previous solutions where we might have had to invest in solutions from Cisco and others to provide that stretch layer 2. So in this scenario, as I say, we work with both Zerto and vSphere replication and Veeam replication, where you can fail over a small number of VMs to the cloud, spin those up, and to then be able to come up on the same IP address. So leveraging the L2 VPN there. Full failover solution, so this is the idea where you've lost the entire data center. Fortunately, it doesn't happen too often, but we were really busy last weekend with a lot of customers in Florida, failing over to our Dallas data center, so really testing that the solutions were working. In this scenario, as I say, some of the other benefits from NSX come in, such as BGP. So if you're able to fail over the public IP address blocks from on-premises to the cloud, that's going to mean you don't have to do re-IPing, DNS changes, anything like that. So that's a lovely feature again coming in. Final couple of slides. We've spent an awful lot of effort over the last 3 years developing our own high-level console that sits on top of vCloud Director, vSphere, vCenter, Zerto, Veeam, Trend Micro, and now vSphere replication as well. So an HTML5 based application, no Flash, no Java, no VMRC required, which allows you to manage all the NSX API integrations, Zerto integrations. We're going to be building in integrations with vCloud availability as well. So my 20 minutes I originally had, I think I've got down into 5. So with that, I'll hand back to Humer.
Thanks, Richard. Cool stuff, yes. Man. So, so hopefully, with those last 2 customer examples, you see the flexibility that you have with NSX, in terms of the different deployments. Now, I just had to cram this last section in here. Again, I didn't cover this in US VMworld, but I just wanted to show you some of the additional coolness. So I'm going to start with, again, this is third-party services within these disaster recovery solutions with NSX. And first one I'm going to cover here is how you can leverage some F5 services, specifically GSLB. So here I have a multi-site environment with Cross vCenter NSX, and I'm leveraging something called local egress. So you can see basically I have this application that's spanning both sites. It's on the same logical switch. And I'm leveraging this local egress feature of NSX where the workloads here will always use the site local egress points, and the workloads here will always use their site local egress points. Why? Because of that local egress feature, okay? So that handles the egress functionality. And what I'm doing is, and this is more I'm generally explaining here, this GSLB concept, but I'm leveraging GSLB to handle the ingress traffic, okay? So I have GSLB appliances installed, there are virtual appliances installed at both sites, and I also have site local load balancers installed at both sites. And I've created application pools at both sites, and those site local load balancers are monitoring those application pools, okay? And all of this information is communicated to the site local load balancers and to the GSLBs, which are monitoring the site local load balancers. So now each of these site local load balancers has their own virtual IP. Here at site 1 and at site 2, okay? So I have A records created in my DNS up here, the GSLB. So when a client connects from the region in site 1, again, this is based on my load balancing mechanism. I'm basing it on region here. When a client connects from the site 1 region, the WIP at site 1 is returned, and the egress and ingress will happen locally at site 1 because of that, okay? Now, at site 2, if a client comes in from that region, the WIP at site 2 is returned, and egress and ingress will, in return, be handled there locally, okay? Now, this is kind of a different way. You can see in this scenario, I don't even have like SRM or any disaster recovery orchestration tool deployed. Now you can deploy something like a GSLB for both active standby and active solutions, and you can also leverage some of these DR tools. But what I'm showing here that's cool is this application inherently by design is already spanning both sites, right? So it's already available at both sites, and the clients locally will always get that local WIP returned on the DNS request. So if this site goes down, basically now if any client from any region comes in and connects, it's always going to get the WIP from site 2. So inherently I've kind of built in this, even without using any disaster recovery orchestration tool, this application inherently is good based on its design, right? Now again, I'm showing the active scenario here. You can use active standby as well. So if I look at F5, how F5 would be used there, I deploy my F5, it's called F5 DNS. They were prior called GTM. I'm still getting used to that name, but it's called F5 DNS now. Those are deployed in my management layer. I have F5 LTMs also deployed locally at each site, and the LTMs are what are monitoring those application pools. So I have a client here, the request comes in, DNS request. I get an intelligent DNS response from the F5 DNS. Again, this is also based on my status of my application pool, status of my LTMs, and the load balancing algorithm I'm using. And the correct WIP is returned for the LTMs. Right here at site 1, it's returned and load balanced to the local application. So the algorithm here, I'm also doing a separate load balancing algorithm here where I'm initially load balancing by region, so the correct VIP is returned, but then once it hits these LTMs, I'm also doing local load balancing here where perhaps they're using round robin. And in the US session for the multi-site, I actually showed a demo of this in part 2 multi-site session. So if you get a chance, check that out. I actually show a demo of this combined with the panorama working together. Okay, so the next service I want to talk about is advanced security, and in this case, I'm going to use Panorama, Palo Alto Networks, excuse me. So here again, I have a multi-site setup, primary NSX manager, secondary NSX manager. I deploy my panoramas, both sites, but they're deployed in active standby mode. So this panorama here is active, and this guy here is standby, and the configuration is synced with high availability between them. So when I create my security policies here at this panorama, they're automatically synced to this other one. I don't have to do any manual replication or synchronization there. Okay? So now if I log into my panorama, my active panorama, I can actually see an NSX Manager plugin. It can register with now multiple NSX managers. So I've registered here with NSX managers at both Site 1 and Site 2. Okay? So I can also deploy my service VMs from the active panorama across all hosts between my sites. Another cool thing here is from the active panorama here, I go to steering rules in the NSX Manager plugin, and by clicking this button where it says auto generate steering rules, it'll actually take the policies I created here in Panorama. It'll automatically create the redirection rules from my NSX managers and push them down. So I don't have to go to each NSX manager and create redirection rules, right? From Panorama, I can create the security groups and redirection rules on my NSX managers at both sites. So pretty cool stuff there. So redirection rules are automatically created, pushed down to both sites. Now I have my consistent layer at top for my management where NSX Manager is being used for up to L4 security, and I'm using Palo Alto Networks for up to application level security. So from active panorama now I can create these policies, push them down to all hosts across both sites, and I have consistent security policy. Again, use L4 with distributed firewall, and then Palo Alto Networks is providing application level security. Now if this guy goes down or were to go down, my standby will become active and I can update and edit my policies there and push them down to both sites. Okay, so pretty cool stuff. And in summary, basically I want to say, one thing to take away from this session is you should look at NSX as a platform for building multi-site and disaster recovery solutions. You have your vCenters, your NSX managers at both sites, and this gives you that foundation with already inherent capabilities, right? But on top of this now, you can start adding even more advanced solutions. You can deploy Palo Alto Networks for application level security. You can deploy F5 DNS if you want to leverage GSLB functionality where you're monitoring these application pools. You can deploy SRM for your disaster recovery plans. You can deploy vSphere replication to replicate workloads. And you can build out these entire solutions. So what I want you to take away from this session is, hey, this is cool stuff, but really, what is NSX for disaster recovery? It's a platform for building these multi-site and disaster recovery solutions, and that's pretty much all I have. Here's our contact info. Feel free to stay in touch. I'll also open it up for questions and stick around if you have any additional questions.